Okay, welcome back. Hopefully you have had enough time to go ahead and go through these questions, and so we're just going to quickly go through and make sure that you guys got the correct answers. Number 2, a student is given a diagram of an atom with 3 protons and 3 electrons. So again, I'm highlighting my pertinent information, 3 protons, 3 electrons. Which statement describes the atom if another electron is added to the diagram? So if another electron is added, what's going to happen? So first you have to go ahead and kind of realize or put into play our little chart that we've been working on. So if another electron is added, remember electrons have a negative charge and a 0 mass. So let's see how will that actually affect my either mass or charge. So protons, right, it has a 3 positive charges, also 3 AMU. Actually it doesn't say anything about neutrons, so let's just go ahead and go on. Letter F, the atomic number will increase by 1. No, the atomic number is only associated with the proton, and that's not what was added. What was added was another electron, so no, that's not it. Letter G, the atomic mass will increase by 1. Okay, if I add an electron, we already said it had 0 mass, so no, it's not going to increase by 1. Letter H, the atomic number will decrease by 1. It has 0 mass, so it will not decrease by 1 either. Letter J, the atomic number will stay the same. True story, it doesn't weigh anything, it will stay the same. And the atom will become negatively charged. Okay, well it had 3 protons first. It had 3 electrons, so 3 negative charge. If I added another electron, which is a negative charge, then my total charge there is going to be actually 4 electrons. So if I have 4 electrons and 3 protons, then 4 minus 3, yeah, it is going to have a 1 negative charge, so negative 1 charge. So yes, absolutely, this is the correct answer right here, letter D. Number 3, which subatomic particles make up the mass? So again, mass keeps coming into play here. So mass has 1 AMU, electrons 0, neutrons 1 AMU. So who makes up the bulk of the mass? Well, protons and neutrons, so 1 and 3. Number 4, if an atom has 12 protons, 13 neutrons, and 12 electrons, what is the charge of the mass? I don't know, let's kind of do some work here. 12 protons, 13 neutrals, you know what, I'm not even going to count it, like whatever, doesn't matter to me, and 12 electrons, 12 negative. Then what is the overall charge of the atom? Well, they cancel each other out. 12 minus 12 is 0. So the overall charge is definitely going to be 0. It doesn't have a charge. Doesn't have a charge. Number 5. Which statement best describes the nucleus of an atom? Again, you should be going back over here and figuring out, oh look, in the nucleus I have protons and neutrons. It makes up the bulk of my mass, so let's go ahead and figure this out. Number 5. Which statement best describes the nucleus of an atom? I'm looking for the nucleus. Letter F. It is a centrally located structure comprising almost of all the atomic mass and having an overall neutral charge. While this is correct, it does comprise almost all of the atomic mass. It does not have an overall neutral charge. Overall, it would have a positive charge. Because remember, if it doesn't have a proton, it's not an atom. So that is not it. Letter G. It is a centrally located structure comprising almost none of the atomic mass. Nope, not true. We already said it's all the atomic mass. Letter H. It is located in the electron cloud. No, it's the nucleus. It's not located on the electron cloud. Letter J. It is a centrally located structure comprising almost all the atomic mass. That's a true story. And having an overall positive charge. True story. Yes, that is correct because they have protons. Positive. Number 6, I realize that this model is a little hard to see, so we'll kind of walk it through. Which model below is the best representation of the atomic structure of a lithium atom? Lithium. So this is kind of a 2-step process. I need to know how many protons a lithium atom has. So I need to use my periodic table. So I come find lithium. Li is what I'm looking for. Oh, look, here it is, lithium. So I see here that it has a 3 for an atomic number. So 3A, remember I'm using 8-man. 3 for an atomic number, 3 for the proton, 3 for the neutron. Now I can remember I can also use man here. M minus A gives me N to have the number of neutrons. So my mass, 6.94. What does that round to? Yes, 7. So 7 minus, here's my 3, gives me 4. So I should be having 4 neutrons, 3 electrons, and 3 protons in my atom. Now I can move on. I'm gonna write it off to the side. I'm looking for 3 electrons, I'm looking for 3 protons, and I'm looking for 4 neutrons. So let's do process elimination right quick. So here's model W. Model W has negatives in the nucleus. Is that possible? Hopefully you just told your teacher no, not it. So I realize it's hard to read. From here on out, each of them have 1, 2, 3 positives, 3 positives, 3 positives. So all these have 3 protons, so that could potentially, all of them could be potentially based upon that. Let's check out electrons. 1, 2, 3, check. 1, 2, 3, check. 1, 2, 3. Oh, look, that can't help me either. I can't do process elimination either. Now for neutrons. This is the part that I said that it's kind of hard to see. As I'm kind of zooming in, the protons are bigger here than the neutrons. While there are 4 neutrons, 1, 2, 3, 4, they're smaller than the protons. They each weigh 1 AMU, meaning they are the same size. So one should not be any bigger than the other. So no, this is not it. While it holds all the right numbers, their size is not proportional. So now you go to Model X. Model X here has 1, 2, 3 protons. True story. Okay, good. That's right. And it also has 1, 2, 3, 4 neutrons. Hey, that's right. And you know what? They're the same size. But there's a problem. The problem is that all these 3 subatomic particles are the same size. Your protons, neutrons, and electrons are all the same size. That is not a true statement. The electrons are so small because they don't have any mass. So therefore, this is not a good representation and not a Bohr model either because they're all the same size. So not it. So let's take a look at why this one is it. So here, yes, we have 3 electrons. Yes, they're smaller. Check. Here we have 1, 2, 3, 4 neutrons that are bigger than the electron, so that's good, and the same size as the proton, so that's check. So same size in here, charges are correct. Both of these are bigger than the electron, which is correct as well. So yes, your answer here was absolutely model Z. Very good. All right, don't forget to hand these in to your teacher. You did a great job. Have a good one, guys.